Saxon Algebra 1. This is a question for Lena or Lena. Thank you for reaching out to me. It's really fun to hear from people who find me on YouTube and follow along. And I'm glad if this is helping you, and I'm glad that you asked me a question. You asked me about the first practice problem in 117 of Algebra 1, and it is a doozy. You're right. The topic is direct and inverse variation squared. We know that inverse variation, well, let's do direct first. That's direct. This is inverse, right? And then we added this idea that sometimes there are squares in them. Okay, that makes it complicated, doesn't it? But there's a formula, a pair of formulas that are introduced in this lesson, and let's put it to use, them to use. The weight of a body, oh gosh, it's physics. The weight of a body on or above the surface of the earth varies inversely with the square of the distance from the body to the center of the earth. Did you just like make your eyeballs spiral out of control in the middle of me reading that? Because mine did. But here's the thing. As I'm reading it, I'm glancing and looking up at the solution to the previous example that's above this practice problem in the book. Here, I'll show you. Right, there are the words. Look, this is exactly the same kind of problem. Isn't that a lovely coincidence? So, it's a good tip for helping yourself out of a jam. But here's the situation. We're saying that the weight varies inversely as the square of the distance. See how I just took the sentence and turned it into the version of this that we need? The weight of a body on or above the surface of the earth varies inversely, so we know it's this one, with the square of the distance from the body to the center of the earth. Do not let the physics psych you out. Okay, if a body weighs 50,000 pounds at a distance of 6,000 miles, then how much would it weigh when the distance is 25,000 miles? Okay, so as you probably remembered, these are two-step problems. We use the first set of information to calculate our constant, which is what this is. Don't ask me why mathematicians like K, we just do. First we find K, and then we use K to find the weight. Okay, so those are the two steps. So let's start with this one. We take this information, we plug it into the formula. So 50,000 equals K over, and this is where it gets a little crazy, 6,000 squared. We have to cross multiply. So that means K equals, whoops, I forgot a zero. Oh, and I put an extra one there. It equals 50,000 times 6,000 times 6,000. Good Lord. Okay, let's multiply 5 times 6 times 6, right? I'm going to do 5 times 6 first. That's 30. And then times another 6 is 180. I'm not going to put any decimals in, but I'm just doing the front, the non-zero digits. 5 times 6 is 30, times 6 more is 180. Now we have to add all these zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how I broke that multiplication down into manageable pieces. Now I'll go back and put in the commas. So, hundreds, thousands, millions, billions. This is 1,800,000,000,000,000,000. Yikes. That is our constant. Are you afraid? I am. All right, now we're going to use the constant to solve the second scenario. Let me just say, this would be a great time to use scientific notation, but I don't want to add more drama than there already is. So we're going to leave that out. I did notice when I looked at the solutions manual, which I hope you have this book as well. Solutions manual. This is the one that gives the step-by-step to all the solutions, right? Not just the answer like you'll find in the back of the textbook, but the step-by-step. And it is such a useful tool. Don't use it to cheat, just teach yourself. All right, so now we're gonna do this same formula again. So the weight, we don't know what it is equal to the constant. I'm gonna write the whole crazy thing out again. Right, 1, 2, 3, 4, 1, 2, 3, 4. Okay, divided by, and now this time we're squaring this number. So again, I'm gonna write it Does that make sense? I'm just using the same formula again to solve for the missing piece. So now what we need to do is we need to take this giant number and divide it by this, which is 625 is what you get when you multiply 25 times 25. And then we'll have 1, 2, 3, 4, 5, 6 zeros. I'm just adding them up. And I would definitely say, well, let's see. Let's just cross off 2 sets of zeros. We can do this by hand. We're not afraid of this beast. So now, so what I did was I basically divided each number top and bottom by 1,000,000. And now I'm going to do the remaining top number divided by 625. All right. 6 into, let's see, I'm going to compare it to this much, right? Because if I do 6 times 3, it'll be bigger than this number, right? Because that would be 1875. But if I do 6 times, this times 2, that should work out. So let's try that. That's 10, 5, 12. We subtract. And we'll bring down. I see the 6 and the 55, and I think 6 times 9 is 54, but 9 times 25 is going to make it too big, right? That's going to bump my number too big. So I'm going to do 8. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. 48 plus 2 is 50. Oh, that's interesting, right? I subtract. And then I'm going to bring my number up here. It's going to be 500 again. I'm going to bring down another 0, right? I've brought down 2 zeros so far, so I'm kind of crossing them off so I can keep track. And look, I know that 625 times 8 is exactly 5,000. So if I put an 8 there, I'll get another 5,000 there. Subtract, comes out to 0. I fill in the blank, and there's our final answer. If the distance from the bloody to the bloody blah is 25,000, then the weight of that object will be 2,880. And let's say, what is it, pounds? Let me look at the problem. Pounds. So let's just add a little libs there, because you know, if there's words in the problem, then the answer deserves words too. And that is the right answer. Yay! I hope that makes a little more sense to you. Again, thank you for reaching out. Feel free to ask me again if you have other questions. Always happy to serve. Goodbye.